Okay, so today we're going to start our third part of Unit C. So you have a new calendar that's going to be passed out to you. All of the worksheets, so this worksheet 6.2b, that's your homework, is in your current blue packet of worksheets. We don't have another packet. It's all, the rest of the year, the rest of the semester is in that blue packet of worksheets. To start class today, we're going to look at 6.2 Visual Approach Lesson Opener. So find that in your packet. We'll pause the video to give you a chance to find that. So at the top, you don't have to write this down, it says it on this worksheet. A function is a polynomial function if it can be written as a sum of terms, and a sum is adding. You could also have subtraction, you can think of it as plus and negative, and where each term is a constant, so that's a number, times a whole number power of x. And remember, a whole number is a positive integer. Including 0. Constant term at the end can occur because, let's say if it's 7 at the very end of the polynomial, that technically has a power of x, which would be x to the 0, and a whole number includes 0. So you see you typed on your paper that there at the top there's polynomials and at the bottom there's not polynomials. So we have examples and non-examples. So for these examples, notice we have only positive whole number exponents on x. The coefficient might be irrational. It could be negative. It could be any number. The coefficient can be any number, but the exponents have to be whole numbers. So there's a 1 here. Now in the non-examples, you have a square root over the pieces of this binomial. We have negative exponents. We have a fraction of the variables, or variables in the denominator. So none of these are polynomials. And then something you have to add to your worksheet. This is not there, but you need to know what standard form is of a polynomial. So a polynomial in standard form is if you write it with descending exponents, meaning the exponents go down. Descending meaning going down. The leading coefficient is the coefficient of the very first term when it's in standard form, and the degree is the highest exponent of that polynomial. So if you're not period 7, you're not sitting in groups. So if you're period 2 or 4, work with somebody that's next to you or near you and decide on your worksheet, these are at the bottom, whether the function is a polynomial or not. If it is a polynomial, write it in standard form and state the degree and leading coefficient. If it's not, you just write it's not a polynomial. We'll pause the video here to give you a chance to do that, and then I will resume and give you the answers. Okay, so this is actually a copy of your exact worksheet. So it's really 9 problems, not just the few that I had typed prior. So for these 9 problems, make sure you're writing if it's a polynomial or not. If it is a polynomial, write it in standard form and state the leading coefficient and degree. Okay, this one is not because of the square root. This one is, and is actually already in standard form. So therefore, the 4 is the degree and the 5 is the leading coefficient. 3 is not because of this square root over the variable. 4 is not because x is the exponent. 5 is not because of the fraction with the x's. But 6 is. Here's why. I could rewrite this as 1/5 x to the 3rd minus 4/5 x squared plus 3/5 x plus 2/5. So 6 is a polynomial. 3 is the degree, and 1/5 is the leading coefficient. Okay, 7 is a polynomial. It's already in standard form, so 5 is the degree, and 125 is the leading coefficient. 8 is also a polynomial. The square root here is just on the coefficient, so that's okay. 5 is the degree, 13 is the leading coefficient. And lastly, number 9, that is not a polynomial because of the square root. Okay, so this is still in your packet. If you look at 6.2b, which is your homework, we're going to look at the even functions now, and you're going to do the odds for homework. I'm sorry, not even functions, the even problem numbers. So let's start with 8 and 10. Now, direct substitution is when you take this value and you plug it in to x. This is what you've always done to find the value at an x value. It's called evaluate. You're evaluating, you're finding the value. So we have to simplify this. That's 2 minus 3 plus 5 minus 1. It's nice when they're multiplied, but when it's just the 1. This is negative 1 plus 4, so I get 3 when I direct substitute in that value. So you try 10 while I write my work here. We're going to substitute in the negative 2, so this one's going to be a little bit harder. Okay, so negative 2 to the 4th is positive 16. Negative 2 squared is positive 4. This I'm going to multiply to positive 6. Now if we do negative 3 times 16, well, let's see, let's do 10 times 3 is 30. And 3 times 6 is 18, so that's negative 48 plus 8, and then I'll add these as 10. Here's negative 40 plus 10, so I get negative 30 as the value when I substitute in negative 2. Now something new is synthetic substitution. This is an awesome process. It takes this direct substitution and it makes it easier. There's less mental multiplying, especially since we're not going to be using calculators. There's less multiplying, there's less exponents to deal with. It really is a great, really cool process. So we're going to do 16, 18, 20, and 22. I'm going to start with 16. So watch and listen very carefully at how this works for synthetic substitution. I'm going to take this x value and I put it in the corner with a little box. And then what I'm going to do is I take all of the coefficients of my terms, but I have to make sure that it's every single value of x. So notice how here in 18 we're missing x to the 5th, x to the 4th. So the 18 is going to be special. So what I'm going to do is I'm going to list the coefficients along here in a line. That's negative 2, 3, negative 5, 2, and negative 6. And then I'm going to draw a line after I leave some space. So leave a space here. We're going to write some numbers on this row. So here's how synthetic substitution works. We're going to bring down this first term, that's negative 2. And then we're going to multiply negative 2 times negative 2, and we get 4, and put it here. And then we're going to add. So 3 plus 4 is 7. And I'm going to do 7 times negative 2, and I get negative 14. And then we're going to add, and I get negative 19. So your whole process is multiply, then add, multiply, then add, multiply, then add. Now I'm going to multiply negative 19 times 2 and add 40 times negative 2 and add, and my answer is negative 86. See how much easier that was? Now don't do this, just watch. If I substitute a negative 2 to all of these, if I do direct substitution, this is so annoying. We've got negative 2 to the 4th plus 3 times negative 2 cubed minus 5 times negative 2 squared. And the rest of it I would plug it in. So then that's going to give us negative 2 times 16 plus 3 times negative 8 minus 5 times 4. Now I can't forget the rest of this. This is going to be negative 4 and negative 6. I got negative 10. Oh, then I have to keep going. And I'm going to prove to you we're going to get this negative 86. This is 32, negative 32. This is negative 24, minus 20, minus 10. And when I add all of these up, we get negative 86. So handling the exponents and then multiplying by the coefficients and then adding the numbers together. This direct substitution can just take a while. It's just not very efficient. Synthetic substitution, multiply then add, no exponents to worry about, no coefficients really to worry about once they're written up here. It's really just a great efficient process. Okay, so let's try 18 because 18 is special. We're missing some x's. So when I set up 18, what I'm going to do is I put 2 in the corner. Now I have to put my coefficients, but I'm going to put a 0 for any x that's not there. So for example, I'm going to put the 1 because it's x to the 6th. There's no x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then 4. So you have to hold the spot of all these missing x to the whatever exponent so that we have it completely in standard form before we do synthetic substitution. Okay. So our first step, we bring down the first number. We multiply and add. Multiply and add. So 2 times 2 gave me 4. Add. 4 times 2 is 8. And add. 8 times 2 is 16. Add. Okay, so 16 times 2, 32. We're going to add that to the 3. 35 times 2 is 70. Add it up. We get 74. So for 18, f of 2 is 74. Okay, so we're going to pause the video here. You try 20 and 22. I'm going to move them to the bottom of the screen so I can do them. Oh look, I already have them down there. Okay. So now check your answer to 20. Put negative 4 in the corner. All of the x's had coefficients, but there's no constant at the end. So you have to hold a 0 for the constant. If you didn't do this, your answer is not going to be right. Bring down the 1, multiply and add, multiply and add, multiply and add, multiply and add. Well now, in this case, it's a coincidence that this number and this number are the same. That won't always happen. You have to hold the spot for this 0. Alright, now let's try 22. Negative 1 goes in the corner. All my coefficients. Bring down the first number. Multiply and add. Multiply and add. Multiply and add. So for 22, f of negative 1 is negative 6. Okay, so now what we're going to do for the remainder of the period, start working on these problems. You can do 1 through 21 odd, all of them, and that is your weekend homework. Put your new calendar in a safe place. It's going to take us all the way to final exams. I'm going to make the last page of this video your answers to your homework, so that way we can pause the video here and you can check your answers as you work.